Greetings students. Today we will study about electric field lines. In last chapter or last session we have studied about electric field. So the today's topic is electric field lines. Electric field lines is a representation of electric field in a space around the charge. The electric field is a vector quantity and can be represented as we represent vectors. Let we have a point charge Q or a source charge Q. Now we will draw vectors pointing along the direction of electric field with their lengths proportional to the strength of the field at each point. I am repeating, now we are drawing point charge. Around the point charge we are drawing vectors pointing along the direction of electric field. I am repeating again. Now we will draw vectors pointing along the direction of electric field with their lengths proportional to the strength of the field at each point. Now, since the magnitude of electric field at a point decreases inversely as the square of distance of that point from the charge, so the vector gets shorter and shorter as we go away from the charge, and they always will point radially outwards from the charge because it is a positive charge. So we'll draw the field lines now. These vectors pointing along the direction of electric field with their lengths proportional to the strength of the field at each point. So as we go away from the charge, the length will get shorter and shorter. And this is the positive Q charge. Okay. So this is how we draw the electric field lines conventionally, and E is strong near the charge, so the density of field lines is more near the charge and lines are closer. Away from the charge and the line are closer. My apologies, away from the charge the field get weaker and the density of field lines is less, resulting in well separated lines. The electric field E can be given as F, the force experienced by the charge, the ratio of force and the charge. So this is Fr upon Q, that is K, capital Q upon R square into R cap. So the electric field is directly proportional to 1 upon R square or inversely proportional to the square of the distance from the source charge. The picture of field lines was invented by Faraday to develop intuitive known mathematical way of visualizing electric field and charge configuration. Faraday calls them line of force. The appropriate terms which we should use is field lines. Okay, we have certain general properties of these field lines. General properties: field line start from positive charge and end at negative charge. If there is single charge, they may start or end at infinity. In a charge-free region, electric field lines can be taken to be continuous curves without any break. Without any breaks. Fourth point, the two field lines can never cross each other. The last point, the electrostatic field lines do not form any closed loop. Next, we'll draw these field lines. See very carefully. Let's say I have a point charge Q, okay, and then I assume if Q is greater than 0, then field lines will be starting from the charge ending at infinity, as this is the lone charge present in this space, this environment. So Q is greater than 0, that is Q is positive. Next, if I have another Q charge and Q is less than 0, it is negative, then the field line will be coming to us starting from the infinity and ending at the charge. Here we can see Q is less than 0 or negative. Next, if I have two charges present, both are positive, then the field line will be as follows. They will be going outwards and they will be repelling each other. So the field line will be as follows. Now, if we have one positive charge, another negative, then one positive charge, another negative, then the field line will start from positive and end in the negative. So the field line will be as follows. These are the graphical representation of field lines. In next class we will study about electric flux, then electric dipole, and then electric field about because of the electric dipole. Thank you.